Hello, Matt Hayden here with GDIT. I'm a vice president that covers down on cyber and emerging threats across the intel and homeland security sector. And today we're here to talk about memory safety with GitLab. I'd like to introduce Joel.
I'm Joel Krooswyk. I'm federal CTO at GitLab. I'm basically the point where government policy and technology come together at GitLab.
So no one better to have a conversation with us about today. We hear a lot in our development and our investments. We've heard about memory safety for a while now, but we really hear it coming strongly out of organizations like CISA, how it needs to be a priority moving forward. When you're working with your customer sets and your product teams, how are you defining memory safety for them?
It may be easier to define memory unsafety, right? We start there. The whole idea of the language that has to be manually managed by a developer when it comes to the memory side. So the concept here is if I'm coding in C or C++ or assembly or a legacy language that I have to use the term pointer, for instance, to manage that memory, we're now in the realm of memory unsafety. And so if you're looking at other languages, they may have the concept of garbage collection or some other automated memory management capabilities. And so we're contrasting those worlds when we get into the memory safe conversation.
So with that being said, a lot of the things that we at GDIT have as a customer base are federal agencies. And when we go to federal agencies and have looks at their roadmaps, talk to them about their modernization efforts, we really want to know where we can insert some of these things. But at the same time, with working with large organizations, where are you seeing them do sort of that first jump into addressing this? And almost from a risk perspective. Like we look at it with the IT aspect in mind, where are your crown jewels and where are you protecting them? But it's kind of hard to get into that pipeline with all the other different priorities that a lot of our CIOs have. So how are you finding the conversation moving with your large customers?
Yeah, historically, prioritization of this has been very difficult, right? This is time-intensive stuff. It is difficult. It's challenging from a skills perspective, a tooling perspective, the size of these applications, right? I mean, we're not talking about languages that just showed up. This is 50-year-old tech a lot of times. And so by now, the malicious actors have figured out how to go after these things, right? And we hear things like, 70% of severe vulnerabilities are located in these memory unsafe languages by now. And so when we look at what people are doing, it's the prioritization of the low-hanging fruit first. Like, how do we take care of these smaller applications? How do we take care of the things that are easy enough to move into a memory-safe environment? Beyond that, things get a little interesting, right? Because you're not going to just pick up this giant monolithic application you have and move it into something new. It's a very iterative, long-term process. And so we're seeing a lot of conversations around how do we do it? Where do we do it? When do we do it? How do we prioritize it? But at the same time, we're also trying to balance out the workload piece, the skill set piece. There's so many other components to making a roadmap for this and understanding what do we prioritize and why. The crown jewel often being the most difficult because of its size, its time, its functionality. There's just so many questions.
Yeah, and we hear SaaS as a solution in some of these areas. We hear cloud amplifies it, but one of the things that we amplify with our customers is there are tools coming online that make life easier, but there isn't a silver bullet. One of the things we hear in marketing and in buzzword bingo speak is, AI is going to help us recode all these things. But AI hasn't made it anywhere near that yet. But I know you guys have done a lot with AI, and could you kind of sharpen our pencils around where AI is and how it really is coming to bear in these types of areas?
Yeah, AI holds immense promise. We're not there yet. And I think the idea of taking AI and just putting it on a pedestal and saying it will solve my problems is something we have to be careful about. There's the human element that has to be in place. And so when you think about AI, I like to think of it as an accelerator, not a transformer. So the whole idea of I'm going to pump some code into AI and it's just going to come out the other side clean, running right, everything's good. We're just not there. So the reality is with AI, if you think about it from the perspective of memory safety in particular, if I have a legacy language, something in C, maybe AI can help me fine tune what I have in C. Maybe it's a bounds issue or something that it can help me fine tune that so that I eliminate some of the memory unsafe risk. Over time, if we look at something like I'm going to move from C into a newer language like Rust, sure, it's possible, but we have to do it iteratively. Again, we can't take that big crown jewel and shove it into AI and it just comes out the other side. There's an iterative process here from multiple perspectives. So the iteration piece is really key. Having people involved that are selecting what needs to be updated, understanding how it needs to be tested in a new language, understanding how to secure that new code. And then as we do those chunks, how do we grow it bigger and bigger to the point where we retain the context, the functionality, the dependency links, all those different pieces that we may uncover as we go, because let's face it, not everybody commented their code for how many years, and we may not really know what we're getting into until we go down that road. So it's still a time-consuming journey, and I think that's the caution. Yes, it's showing a ton of promise. It's doing really neat things around explaining what it can do, what an application is capable of. There's a lot of things that AI is giving us, but this is going to be an incremental or iterative journey for sure.
So it sounds like incorporating that AI tool set and modernizing the code language, you're not just recoding, you're actually improving software as you move forward. Are there use cases or kind of success stories that you've seen where people have started with a large legacy platform and through this, maybe they're going after targeted memory unsafe risk, but at the same time, they're getting that value add at the end?
We're starting to see it, right? The stories are slow in coming because we're pretty early in this journey. But the reality is we're seeing a couple of use cases in particular that are targets. One is in the mainframe world where we've got a lot of applications that have run for a long time. Cost containment always comes up, among other things. But some of those legacy languages, it's, well, how do we move off of that old assembly code, which is memory unsafe, into something newer? When you talk about refactoring or converting code, that's a big deal, right? This takes a lot of time. Well, if we can start accelerating that, when we can start looking at, I'm going to move to a different language potentially, maybe I can clean plate my technical debt pile, my security debts. I can eliminate a whole class of vulnerabilities. Any of those conversations may hold true. Well, that's high allure type of environment. Like that's a target. That's something I want. That has a lot of value. So what we see is a couple of use cases. One is I have something that's on my mainframe that's been there a long time, and it's time for me to get that old assembly code converted to something newer, Java or something else. And so we're seeing a lot of that use case in particular of how can I accelerate that? Because this has been around a long time. There's no comments in that code. I don't really have a developer that understands it anymore. What do I do? Mm-hmm. So AI can help us accelerate those moments, again, iteratively, right? We're not going to big bang that. The other side of that, though, is kind of a success story concept here, and it's the idea of the monolithic application, the big old application that's been running in your data center forever, and you need to make room for something new, or you have a cloud initiative. One of those stories looks like taking a monolithic application written in C, breaking it down, moving it to the cloud, and breaking down into microservices in particular, which allows your code base to shrink. And so this particular story takes a code base and shrinks it by nearly 90%. So now you only have 10% of your code doing the same functionality, which sounds great unto itself. And then you find out the benefits of scale, right? I can run this application 50 times faster. I can serve 50 or 100 times more users. Well, these gains that's really measurable, right? That's something I can put my finger on and say, that was worth doing. So when we talk memory safety, there's these other tangible benefits on the other side as well as we consider modern methods, modern languages, modern compute, and some of the other options that are out there. It's just, again, challenging to prioritize that sometimes.
Well, and it's also a resource conversation, but it looks like that there's a give and a take, and investing in there actually can free up some of those resources to do other things. So that's an impressive thing to hear, that it's got some successful paths in place so that we can have those conversations with CIOs and it resonate, because at the end of the day, everybody's got a boss, and so you have to give them that elevator pitch on how the value is being added by these investments. And So recently we had a bad IT day around the world. And so it led to a lot of things that resonate with a similar type error screen that we're used to seeing with a memory safe application issue. So are you seeing that this opens any doors or really empowers that conversation we've been having about priority with a lot of CIOs and CISOs across the board when you're having these types of engagements on, we really need you to get after this problem?
I think what it's really unlocked, and it's interesting because the memory safety piece hasn't come up so much, but all the surrounding processes that would be applied to a memory safe conversion have come up. The idea that I have to test everything repeatably, reliably. I have to make sure I secure everything in the same manner every time. This concept of repeatability really comes to mind, and processes. Are my processes robust enough that that can't happen? Whether it's happening to me or someone else, it just can't happen. And it also made us look at what legacy technology versus new technology can do for us, because it affected everyone a little bit differently depending on what platform you're on or what version of a platform you're on. And so when we step back from it, we say, okay, do we have some things that are running in a closet someplace that are really, really old that we need to revisit? And what's my risk to some unsafe code running someplace that may put me in trouble in the future? So it's really a tangential conversation, but it did open all those closet doors for us.
And that's been beneficial. Never let a bad thing go to waste, sadly. But I'll tell you, Joel, this has been a great conversation. The dialogue on memory safety has a lot more to go, and so we'll keep having this conversation as we go, but it's been a great one today.
Thank you very much.